Good morning, everyone. Thank you very much for taking time out of your busy schedule to join us today. My name is John Krajewski. I am based here out of this office. I joined Wonderware back in April of 2000, so I'm now going in my 26th year in this organization. I started as the guy who used to build demos with the products to hand off to our salespeople. Today, my responsibilities are I'm the Vice President of Product Management, running work for the HMI and SCADA business unit. I have 4 peers within the organization, and so we have Chloe Smith, so she handles all of our advanced applications. MES would fall under that area of the portfolio. We have Mana Afshari, who she manages the PI system and all the things that fall under that area of the portfolio. We have Brian Hughes, he manages all the things that are responsible for the engineering side of the portfolio. And we have Todd Brown, and Todd is working on Connect. And Connect for us, the way we think about it in portfolio, I think the best analogy, at least for those that have been here around and seen kind of what we did with System Platform, when I first joined Wonderware so many years ago, we had a bunch of individual products, but those products dealt with things differently. Everywhere you had to go define something, you defined an asset again, you defined a connection to data again, right? And so what has happened over the years is we've had a lot of products added to our portfolio, right? So we've added, you know, even in the HMI and SCADA space, when I first got here, we had one, it was InTouch. And then we found that there were markets that had more demands, and so we built System Platform. System Platform was originally designed as a platform for us to build new applications and things upon. But then over the years, we had mergers and acquisitions, so we brought tools into it like Indusoft, which came to us, and that now is our AVEVA Edge solution. We had, Schneider had acquired us and brought to Cytec to our business as well, which is another HMI and SCADA product. We also have our Telvent business, which is our midstream, which brings us our enterprise SCADA solution. And so things have kind of fragmented a bit. Connect is that great opportunity to kind of redo again what we had done with System Platform, is building a platforming technology for us that we can utilize to unify our portfolio. So that the things that we often see, where there's different configuration tools and repeated information and copying and synchronizing and things, our focus and our strategy is to reduce that through things like Connect. Now my focus here is going to be mostly on the area that I refer to as HMI and SCADA, but I'll be the first to admit to you, I don't like those terms. And I'll share a little story with you. I remember one time when I was working with Foxborough, who uses your Foxborough DCS distributed control system, utilize our technology as the human-machine interface on top of their distributed control system. And I was waiting to take a meeting, and I was sitting in one of the lobbies, and I saw this book that said, 100 years of process control. And it showed, things that they were doing over 100 years ago and using pneumatic controllers and things like that. And when I went into that meeting later that day, the guy described himself as we're a distributed control system business. I said, that's not what the book in the lobby said. The book in the lobby said you're a process control business. I kind of keep that in mind here because I don't think we're an HMI and SCADA business. We're a digital operations business. Rashesh described that in terms of the phases we see assets being managed, right? Managed through the design, build, operate, and optimize. And when operations may not be done via HMI and SCADA, I don't want to be sitting on the sideline having my own Kodak moment, for those of you who know Kodak is and what happened where they forgot that they were a photography business and not a film business, and they seeded the market. So my thinking on a day-to-day basis is to look into kind of what happens inside of, make sure I've got the clicker going here. Okay, the down button is the one I want. So I often look into things like the trends that are happening in the industry. What are our customers doing? What are the technologies that are happening around the marketplace? What are the things that are happening inside of overall the markets that can affect us? I think of things that are happening in our customers. What are our customers trying to do? What problems are they trying to solve? Because very often those things will change over time. I think a lot about the technologies that we have in place that can help us to accelerate these types of changes. I think a lot about the market things and things that are happening inside of the market. Now this afternoon I have a session where I'll go a bit more deep into this, and so there's a session where I'll talk about this, and I look a little bit more into the future. I struggled a little bit with how to kind of discuss what I want to cover today. I think today my focus this morning is going to be on the near term, kind of like what's the next year look like? But where are these trends going to send us over the next 3 to 5 years? That's kind of where I'm going to be talking this afternoon and kind of things that I see. I do believe that it's an exciting time. It's an incredibly fun time to be a technology person. If you look at anything, I mean, anybody who's ever played with AI makes it really challenge everything that you're doing, and how do you accomplish it, and how do you go about it. And so it's a very exciting time, but it's a challenging one at the same time. For this morning, I'm going to focus in on something that's on the bottom left-hand side, referred to as digital transformation. Digital transformation is a comment or a topic or a phrase that your buzzword that you hear a lot. And what does it tend to mean? And so for a lot of our customers, what we find it means to them is the fact that today that they have more data than they've ever had in their entire time. What we find is that customers also link into a bit what I call software sprawl. More and more departments exist at customer organizations. Each department buys their own software packages, right? So these guys buy HMI and SCADAs, the guys over here buy MESs, the guys over here are buying a GIS system, guys over here are buying an inventory management package, guys over here are buying a maintenance solution, and none of them were ever designed to come together, right? They were all bought independently, and then somebody says, make it all work together, right? And then somebody, maybe it's an engineering department in your organization, maybe it's an SI who sits there and scratches their head and tries to figure out how do we bring this all together. As we look into the future, it's kind of solving a similar problem than when we go back to solving what we call the islands of automation. The islands of automation is where you just go out there and say, hey, you look, I got a PLC from vendor A, or another one from vendor B, another one from vendor C. How do I bring that together into a common solution? I think the things we did around system platform nailed that space. When we start looking at what I call the islands of information, that's kind of where digital transformation starts to change, right? It starts to, how do I start bringing together those islands of information? And typically when we talk about, navigating this digital transformation, I ask questions like, who would benefit from access to operational data? I ask that simple question because traditionally, when we talk about a human-machine interface, its scope of who consumes it is typically limited to the guy who's going to be operating the thing, right? He's the one who's going to be pushing buttons that's going to change set points, acknowledge alarms, change operational state of the asset. But increasingly what we're finding is that customers are looking to fulfill or put into the hands of individuals information so that they can make a better decision faster. And so increasingly, we're not finding that the target is just the operator. Increasingly, with the target for that converged experience could be people in all of those different departments I described. So if the guy who has the maintenance stuff, does there ever times where he needs to know the current operational state? I mean, that certainly could be valuable to those people. Somebody's doing scheduling. Would they like to know currently, what kind of alarms are being experienced? Or, increasingly what we're looking for is how do we share that information across an organization? And that's kind of how I think a lot about digital transformation. And it's not just the basics of what we've always done, monitoring and control. Often we call ourselves monitoring and control in this business. But I look in terms of what type of activities would benefit from having access to operational data. And the answer is a lot. Right? I don't know that I could ever come up with a complete list in terms of what that is, but increasingly we're finding that the scope of what we're trying to supply is much larger than what we ever done. And so that's where things like Rashesh was showing you, most of what Rashesh showed you is not control. Most of it is to provide the circulation of that information across an organization to facilitate a much broader set of activities, which I've illustrated only a few on the screen at this point. So when we look at this and we look at how do you go about digital transformation, and these are not even my words, I've taken these from words in the community of organizations that have been focused on how do we navigate this digital transformation. There are typical steps. Now we've been using a lot of these words for a lot of years, and they've changed in some cases, but we talk about how you have to connect to the systems, be able to collect and organize that data, store it, analyze it, visualize it, find patterns in it, predict outcomes, report on those activities, and solve problems as a greater organization. And what I'm going to walk you through here is how we do that in something I call AVEVA Operations Control. So for many of you, you probably have bought many of the products I named earlier. You bought an InTouch, you bought a system platform, you bought a historian, you bought some element of that. So what is this AVEVA Operations Control that we're talking about? So when I was honored with the opportunity to take the role as vice president and take on all these products, I looked at them and one of the first things I said is, how do we sell all of this, right? And I realized how difficult it is that we only had a small number of customers which were leveraging all the capabilities which we possessed. Largely because it became commercially prohibitive, too expensive, right? Too hard to buy it all together. So one of the things that I focus is on, I want to be able to empower our customers with the full capability that we possess as AVEVA. So we created a package, and I looked at how other organizations had approached similar problems. How did Microsoft do this? How did Adobe do this? How did some other organizations that had created a broad portfolio of things bring them together into a common solution? And so I originally started with the notion of Microsoft Office, AVEVA Operations, and then we realized, well, there's a bit more in operations inside of AVEVA than we had on my portfolio, so we called it AVEVA Operations Control. Although I can tell you I tend to arm wrestle and wrangle with my marketing guys that I'd like to drop the control word, because so much of what I'm about to share with you is not so much about control as it is around other elements of the daily activities our customers engage on. So what I'm going to do for here is talk to you about what are the products that we use, and what are some of the things that we're looking to do to improve upon how you connect, collect, store, analyze, visualize, find patterns, predict, report, solve. And I won't be able to give you all the details, or I'd be up here for 6 or 7 hours, so I'm going to be able to do it hopefully in the next 20 minutes and leave you wanting more. So definitely this will lead you into some of the other presentations that are happening here today, and hopefully have more conversations with both myself and the other teams here that are here to support you in this event. So I'm going to start off with Connect. Connect is something that it's interesting, is that at Wonderware there's often a lot of, for those of us who've been around quite a long time, there's often a lot of different opinions about what brought Wonderware to such prominence. And I've always had the strong opinion that the I/O server toolkit was one of the things that brought Wonderware to prominence, because the key thing that they differentiated upon at that point in time was we could connect to anything, right? We crowdsourced things before crowdsourcing was a term that anybody knew what it was, right? We put these things into the hands and redistributed these drivers to people. And so we've been strong in this area, strong for many, many years. So how are things changing now? Well, classically, when you're working on communication drivers in the past, it was very much a configure and then send it out. So I happen to know that this register and this PLC represents this value, and you configure that. Ultimately, what we're finding here is that the devices themselves are changing. So rather than being passive, they're more participant in an active communication of what's in them. I could discover them. I could discover that information. I can discover its namespace. There are open standards that are kind of leading the way in this space. OPC UA, which has been around for a long time, but still I don't know that it has completely seen the potential of what it's capable in terms of connecting to something that has an OPC UA server. Increasingly, we're starting to see hardware that has OPC UA servers built in. That way I can connect to it and I can discover its namespace. So that means instead of me having to go and build it, right, creating a bunch of spreadsheets where I have this row which is the I/O address and this row which is the name, I can just go connect to it and suck it in, right? And that's kind of what we refer to as edge-driven. We've been doing this in a number of ways. We've called it auto-build in some cases, and we're looking at other standards and how we do that in terms of edge-driven. So other things in terms of strategic direction of things we're talking about here is that increasingly when we worked with system platform, we focused on what's known as scalar data types. Those are things that tend to represent field data. So I've got a float, I've got an integer, I've got a Boolean, right? But increasingly when you're working with IT data types, it's different. I may have a JSON package. What is that? How do I deal with that? How do I parse that information? And so increasingly we recognize the challenges of the future are going to require us to even think down at the data type level differently about how we approach these problems. OS agnostic and portable. It's interesting because I was challenging my R&D organization, who very often would refer to themselves as a Windows shop or a Microsoft shop, and said you cannot do that anymore. In this day and age, customers very often want to be able to run on a Linux box, or they want to run in AWS. Or they want you as the vendor to host it as a software as a service element. I've had some customers that say, will you host your SCADA for us in the cloud? Because we don't want to put any hardware on the plant floor. Increasingly, I would say that's not the dominant, but it has started. I've had some customers ask that of us. And so you'll see this OS agnostic. I won't continue to repeat it through all these, but you'll see that it's repeated over and over because I see that's an extremely important direction that we must go. Improved diagnostics, and open standard focus. Now this next thing you're not going to be able to see very well because it's tiny text on the screen and you're just going to have to listen to my voice. But on the left-hand side of the pane, where we're seeing here is that we've made a connection to an MQTT broker. This is the model that's exposed inside of the MQTT broker. You'll see a button over there where the cursor sits where it says Generate Galaxy. In essence, what this is doing, it's a tool that will connect to the MQTT broker, discover the model, and create the system platform model for you. So you don't have to build anything. So that engineering activities, that time to value, goes to a much, much faster time for you to be able to establish it. This is kind of the direction we see industry going in general in that area that we describe as connect. Okay, let's see if I can get this thing moving forward here. So once we've gone on to connect, we go on to collect. So what is collect? And very often in our case, collect is represented by something we often call an HMI or a SCADA. But when you look at collect in the general sense of it, the collect area is the things where I'm going to take that data and I'm going to structure it. So for example, let's assume that I have an OPCOA server, I've got an MQTT broker, I've got some Siemens thing over here, some Rockwell thing over there. What are the chances they all have one unified data model? Pretty much zero, right? Pretty much zero. So how do I normalize that into a consistent data model? There are different varieties of data models. One that tends to lead out there is the ISA 95 model, which starts enterprise, site, area, line, cell, which is a common one, but not the only one. I would see that in data centers, they have over 20 levels of depth in their consistent data models that they do there, and so it's a bit different, the things that they do there. So what we look at here is that there's the things that need to be consistent. For those of you who use InTouch, we introduced UDTs, or user-defined types in InTouch. I think about 2 releases ago we introduced those, and we're leaning more heavily into UDTs because structure, at one point structure was kind of the domain of you were going to use structure, you use system platform. When I realize now that, as a former PLC programmer, when you program in PLC, everybody programs with structures. Nobody programs with registers anymore, at least not unless you're using really, really old equipment. And I know some of that still exists, and it has to be used in your plants. But if you're buying a brand new piece of hardware and you're going to program it, you're probably going to use structures to program it. And so it's no longer the domain of only the few, it's the domain of the many. And in the future, I don't expect that the structures that live inside of InTouch and the structures that live inside of System Platform and the structures that live inside of the Pi system and the structures that live inside of Connect to all be different. I expect them to all be the same. And so that normalization begins as close to the asset as possible. You'll see other things that happen inside of the industry where you'll find like OPC companion specifications or SESMI data profiles, which are starting to say, let's start with that core structure, the enterprise model, can we bake it in at the edge? Can we have it originate so it's not just a data model that originates, but a consistent enterprise data model that originates at the edge, which could accelerate this path that we're talking about in terms of getting that consistency. So one of the things I would say here is that when it comes to HMI and SCADA, there is probably more than they share than they are dissimilar. Very often the differences between them are the scope of what they do. Maybe often it's the people that are doing it, whereas the HMI is typically one that's built by the guy who programs the PLC. But we'll find that the guy who builds the SCADA very often is a SCADA engineer, probably has a computer science background, maybe less a controls background. But the problems they're solving, the thing they're doing, are very, very similar. And so there's some exciting things that we expect to be doing there. And so, one of the things that we're going to be focusing on is ease of use. One of the things that I beat my developers up a lot is I think in the past it was acceptable to have your user interface instrument your architecture is the way I describe it. So inside of System Platform, the fact that you're creating app engines and creating platforms, that was the software architecture chosen by the giants that kind of did that work. But ultimately what I asked them is that, so when I want to create a new data connection, should I start with an area or a DI network or a proxy object? Why don't I have a button that says connect to data source? Why don't I have a button that just says connect to a database or an API or a PLC or an MQTT broker, not exercising the architecture? And so this is kind of a philosophical difference amongst how we're going to go into the future and really focusing on ease of use. That's a bit longer term in those things, but you'll see other things, edge-driven, OS agnostic, server and service-based. One of the things that's important about server and service-based, for any of you who know about software architectures nowadays, you'll find things out like microservices. Microservices can live inside of containers. Containers can then run on the edge devices and things like Linux. They can run in cloud services like Amazon or Google or Azure. But the key things is that they cannot do a lot of the things that have classically had. For example, no user interface. What are examples of user interface? The IDE. The system management console are all examples of user interfaces that we have to now make services. We have to ensure that they become services, which could be web servers, and you'll see me sometimes refer to this as web everything, right? Because web everything becomes some things that you can route through those container services. And so I think a lot of software architecture changes are a front of us, and that's going to be an exciting time for us because we like to do those types of things. But if it comes down to ease of use, there's also a lot of blocking and tackling. So there's going to be a version coming up here soon called 2026, which will go out in the second quarter next year in 2026. And it's chock full of like a lot of like what I call quality of life improvements. And here's a video that shows you an example of one. Again, the user interface can be kind of dense here. You might have a hard time to see it. If you ever worked with system platform and you have to unlock something, let's say you have a multiple hierarchy derivation. I have to go to every point in that system and unlock it. And so you'll see there's a new icon that's right there in the black that shows unlock with an arrow down, which unlocks it all the way through the derivation hierarchy. So that if I have 10 levels of derivation, I can now go to that unlock and I can push that unlock through my entire model. Probably save myself an hour, right, in terms of being able to do that. And so that's an example of, and they're littered with these types of examples that are happening in the System Platform 2026 version, which hopefully we're going to be going into beta late this year on, so we'll hopefully get some more and more customers working with that. But again, this is kind of an examples of not just all of the high-level architecture stuff, but the blocking and tackling of things that are near-term and near and dear to our products at hand. I'm going to move off of collect and onto the store area. And in the store area, that's been the AVEVA historian. And the one question I face most commonly is, now that you guys bought Pi, is the historian dead? I face that question on almost a daily basis. And I will tell you that the answer to that is absolutely unequivocally no, because the Pi system does certain things extremely well that the AVEVA historian doesn't do. However, the inverse is also true. The historian does things extremely well that the Pi system doesn't do. Store alarms, provide data for historical data replay to the process visualization display. Be able to provide historical summary custom properties that can tell you things like averages on the fly directly in the graphic elements. There are certain things where the AVEVA historian was designed to be a historical data record in support of process control, whereas the Pi system was more designed around enterprise level analytics and opportunities. And so one of the things that we have changed in terms of our strategy with regards to the AVEVA historian is that I don't push too much on the strategy of AVEVA historian being a tier 2. Because that's where Pi lives. And so we've improved our integration with the Pi system by being able to push data models so I can populate asset framework from AVEVA historian. So I can push all of my system platform model into AVEVA historian. AVEVA historian can then handle the replication and the store and forward over to the Pi repository and replicate that so that we have a common model, again, so we don't have to manually synchronize those things. And Rashesh talked a bit about AI, and AI, man, that's an area where there's so many things going, and we've got a lot of proof of concepts that are executed right now, and I'll share with you some information about one proof of concept that we're currently running, which is how we can utilize the AVEVA historian utilizing MCP servers. Now, for those of you who are not the nerds in the house and going, what's an MCP server? I will tell you it's just the technology by which you can take a large language model like a ChatGPT and ask it questions about software. And so it exposes the APIs from software to these large language models. So you can ask questions like, hey, what was the best batch that I ran this month, right? And it would be able to go up there and be able to objectively look at this and try to identify what is the deviations, which ones were good, which ones are bad. And it's doing it by exercising the APIs. Then one of the reasons I asked the team to look into this is because I recognize that most of our customers probably use about 5% of the retrieval capabilities the historian has. It has way improved retrieval capabilities than anything else out there in the marketplace, but it requires significant knowledge about how to write the select statements and the transact SQL and the things that are happening. It's not for the faint of heart. However, this could abstract all that, so all you have to say is give me the result and let AI figure out how to work all that out for you, right? And so we're excited to do this. Now, I will tell you that at the same time, I don't have a release timeline for this or a release date expected right now because it opens other issues. MCP is not very secure. In a world where security seems to be coming out of everyone's mouth, MCP is not secure, so we're trying to figure out how we do that. The other thing is that if I start asking this AI questions, could it ever overload the historian to the point the historian's not able to do its primary job, which is collect the data? So I would say this is an area where it's probably more of the R in R&D, where we have to do the research first. It only took us about a week and a half to build the MCP server, which was exposing the entire API set to do this, and then we plugged it into a Claude instance and started asking it questions. But now we're trying to figure out, can we make it viable as a supportable, dependable product that doesn't ever impact your production? Because the last thing we could do is say, hey, here's a new feature, but if you use it, you might go down. Like, we cannot do that, so we have to be somewhat careful about how we take those technologies. But we're certainly going to be investigating this much more deeply as we go through that. Moving past into the analyze space, we have a very rich set of capabilities for analyzing information, whether it's historian trend, historian query, we've got the Excel add-ins, we've got reporting solutions. We've got probably too many solutions in this area, and so I've been trying to push the team on how do we consolidate this experience, how do we bring those things together, how do we leverage more of Connect, how do we make this, again, OS agnostic. And so we're doing a lot of work here on even doing things like single sign-on, so that if you sign on to your application, any of these secondary applications are automatically signed in, so you don't have to sign into the trend application or sign into the reporting solution. So we're doing things, again, also allows you to do multi-factor authentication and that stuff, and so that those are all elements that are happening in the near term. Moving on to the visualize element, for those of you who have started using the tooling we call Operations Management Interface, or OMI, we called it OMI as opposed to human-machine interface because in the future we do feel like it's going to be you interacting with your operation, not interacting with individual machines. And so an operations management interface was originally designed around this software sprawl problem. And it's now become the visualization technology across AVEVA. So everything Rashesh showed you before was running on what we now call VizCore. VizCore in the back end is OMI. VizCore is going to be running with InTouch in 2026. Now, it's not going to do everything. For those of you who have said, well, yeah, OMI is not InTouch, it's much more complicated. We now got it so that you can take the simple windowing capabilities of InTouch and run it in that runtime. So that we have one set of runtime to work with, one set of things to worry about from a cybersecurity perspective, because I can have one technology that I really make sure I pound on that and make sure that's super cyber secure. But I can also extend it into all the things that Rashesh was showing you and host it in the cloud. It is the first thing that we have done that's truly OS agnostic already, and we're ready to go. And I'll show you this in a little video that's happening here. So in this particular demo video, you're actually going to see it's an OMI application. They go up here and they install it as an application. You may have seen in the prior slide there was a bunch of things that was saying WA, which stands for WebAssembly. When things are built on that technology stack, we can then install that as an app. It's called a progressive web application. I can install this on a Windows computer, I can install it on an iPad, I can install it on an Android. It is truly OS agnostic in terms of that. And so it's the area with regards to what we're talking about earlier, being able to be truly OS agnostic, we're the furthest ahead, right? So we decided not to go and do everything at once. We decided to go those areas that were most going to give us quick wins, if you will. We kind of went in that direction. Some would argue how quick that is, but we keep pushing into this space, and I'll talk a little bit more about this in a second when I start talking about some other elements. So down under Find Patterns, AVEVA Operations Control now includes Connect Data Services. So what is Connect Data Services? Well, for those of you that have been utilizing Insight, when we made the OSI acquisition, we recognized that we had two technologies that solved similar problems. Provided at an enterprise level through cloud services, the ability to store time series data and be able to provide information to be able to visualize and analyze that information. However, the approach that had been taken by the OSI Cloud Services, what is now known as Connect Data Services, was a bit more mature. And so we decided that that was the best long-run bet. Right? It was the one that was built on the more modern architectures. I think there were some great advantages in terms of being able to run things stable, being able to run things as microservices, disaster recovery, a lot of things that were improved. So our focus is shifting from Insight to Connect. So for those of you using Insight, should you be afraid? No. Because on the back end, it's our job to insulate you from that. Eventually, Insight just becomes Connect, right? So that's not a problem for you to worry about. But it is going to be an opportunity so that for anybody who's ever had Insight and had issues with performance or even uptime, a lot of those things will be addressed by the investments that we've made in Connect Data Services. So this is going to be a net win for everybody in terms of the things that we're doing there. So moving on to Predict. Predict is actually what we call AVEVA Advanced Analytics. And I think Rashesh might have mentioned a little bit about this earlier. So inside of this, what we find is that AI has been a trend that's been around for a few years. And one of the things we've been investing in AVEVA Advanced Analytics is this ability for us to take more of a point-and-click approach towards AI. I find that many of the people I speak to, very few of them will identify themselves as data scientists. right? They don't say that that's not their core functionality. So how can they take advantage of these technologies without having themselves become the authors of AI algorithms and such? And so that this is a collection of a number of algorithms that help us to identify either anomalies or perfect quality or batch or those types of things, and identify things that are very manufacturing in orientation, very industrial in nature in terms of its approach, and make those algorithms available out of the box. This does run as a cloud service, and so one of the things we're working on here is that how do I do better plant floor interoperability? How do I provide the results of this back down onto the plant floor? And clearly that's going to be through Connect. And so this is an area where we talk a lot about hybrid cloud solutions. Hybrid cloud solutions are part where elements of this may run in the cloud. One of the things I found at times is that whenever I introduce something and I say it's a new server, I hear groans. So we got a new server. God, I don't want to buy another server. No, I don't want another piece of thing to manage. And so this is one of the things where you need the server capacity because you need mission critical safe control that you have. But when you want to do things that are not responsible for mission critical control, like an analytics, we can offload that workload to the cloud, and so that have these things interoperate. And that's what we tend to refer to as hybrid cloud. And so this is something that we're working very strongly on with AVEVA Advanced Analytics. Okay, I'm already at time and I'm a little bit behind, but I think we'll be okay because you have like a 50-minute break, so I'll steal some of your break, my apologies. Connect visualization services. I mentioned to you with the visualization technology that we call VizCore, which was derived from the operations management interface, that we're now being able to host that in the cloud. Rashesh showed a number of examples of that just a moment ago with Connect visualization. And one of the key things here is how do you perform typically remote access? Now, not remote access for the purpose of control, but remote access for the purpose of data sharing. I remember I spoke one time with a customer who was using System Platform to manage a country's whole rail system, and they were managing, if you know what points are, they're the things that tell you whether the rails are pointed in the right direction when they're changing the lines there. And he said, I have over 9,000 people that I need to have access to their real-time solution. How do I do that? And I remember because he asked me about 10 years ago, I said, I don't know. So frankly, I just don't know. It's what we ended up doing was creating a custom web application that they could hit there. So, but you know, even then, the load was difficult to manage. In this case, it's trivial because the resources, that's the one thing the cloud is great at doing is what's called elastic resources. When you need 9,000, it automatically spins up the resources. When you don't, it spins them down. You only pay for what you use. And so the cloud is perfect for these types of things. So remote visualization will increase the change. Some of the things I think you'll be doing less in the future. Setting up VPN tunnels for remote access through RDP clients. I think those will be a thing of the past pretty soon, right? Because you'll be able to utilize technologies like this to eliminate those on-premise servers, to also eliminate remote desktop as an attack vector within your company's cybersecurity stance, because they have a lot of IT people give me that view of life, right? And so some fantastic things that are happening there. So we have added this to AVEVA Operations Control, so that now with every customer who has operations control has this now. And we're working on being able to take your on-premise applications and publish them along with the data to Connect so that you don't have to stand up a server. You just go publish, and it actually can utilize our connector to publish through the routers and navigate your DMZ so we can publish out to the cloud securely, single directional. And this is an example of, this video was one that we took at the Prove It conference where we were actually demonstrating it earlier. That was like February of this year, where this was the OMI application that was running on premise, but we actually launched it from the cloud. So this was an OMI application we took from on premise, published to the cloud, redirected its data to the cloud data, to the cloud data streams, and we're able to show kind of the exact same experience that we had shown in terms of the on-premise experience, but absolutely 100% cloud hosted.